Hey everyone, welcome back. Chad or Patriot Astro here. Today we have the final video in my recent Astro MiniPC series. In this lengthy video, I'll take you through installation, configuration, and testing validation. I was on the fence about whether or not to split this into two separate videos, but in the end, I felt it was important to those that wanted to understand the entire end-to-end process that I kept it together all in one place. I'll of course set up YouTube's chapters feature that can be used by you to jump around or find your place. This will include Windows OS configuration and my end-to-end process for downloading, installing, configuring, and testing everything needed to turn this into an Astro PC capable of controlling and automating my telescope and everything attached. I'll even include getting Nina and SharpCap up and connected to your equipment, as well as validating your plate solving and PhD2 guiding. If you missed those other videos, you may want to go back and check those out first or circle back to them later. Video 1 talked through MiniPC hardware selection and went deeper into understanding the processors, memory, storage options, and bus speeds often found in these fanless PC designs. We also focused on how an NVMe SSD drive as an upgrade could be a great option, especially for those of you doing higher speed imaging like solar, lunar, and planetary. In video 2, I took you through reinstalling or migrating the Windows operating system over to one of those NVMe SSDs to benefit from those higher performing drive speeds. And now today, we pick up where we left off at the end of video 2 with an assumption that you have Windows installed and a user account you can log into, but potentially unconfigured beyond that. So you either just completed the installation or migration of Windows, or just booted your MiniPC for the first time and created a user account. For those of you following the series, you already know I've been using a Melee Quieter 3 as the MiniPC throughout this process, but there are many other similar systems out there that would work just as well. And today's process will work for any of those systems too, or a laptop, or anything else you might even have. I do need to add some caveats to the video, however. Making build videos like this is challenging because everyone has slightly different needs. Maybe you just have a mount and a color camera attached to a lens or telescope. Maybe you have a guide camera. Maybe you added an electronic focuser to keep your images sharp all night. Maybe it wasn't a color camera you had, and because it's monochrome, you have filters and maybe an electronic filter wheel. Or maybe you're like me and also use an ASCOM connected flat panel, polar alignment camera, and even an electronic rotator. Oh, but it gets even worse and more complex when you start to realize it's not just the type of equipment you have, but the manufacturer and model as well. So how am I going to go through building a system in a video meant for everyone, but using equipment only designed for me? By sticking to a process. So let's talk about that for a minute. I've broken my overall installation, configuration, and testing process into two major sections, indoor and outdoor. The indoor section is everything you can do without a view of a clear night sky. You can do this indoors on a rainy day if you like. You might be surprised at how much of this you can complete before heading outdoors for the first time. First, I'll take you through the Windows operating system based configurations and settings changes I make to my own Astro MiniPCs. This will include everything all the way up through how I prepare and configure remote desktop connectivity between my systems so I can control this MiniPC from inside my house. Once Windows is ready and we can connect remotely, we'll start going through my download and install process of all the hardware devices and software applications we need to be functional. We will get everything working one step at a time, and even start getting applications like Nina and SharpCap working with our equipment. We'll do this indoors without a night sky. Speaking of that clear night sky, at some point this will become a necessity. The outdoor portion of my process will cover final configuration and testing of our equipment and applications through real-world usage. We will start by having you set up your telescope outdoors and only roughly polar aligning it. We'll then validate several pieces of hardware as I take you through configuring autofocus in Nina. Once that's ready, we can move on to polar alignment in Nina using a plug-in. Even though I have a pole master for alignment, I know most of you don't. Additionally, using this method for polar alignment gets you familiar with some of Nina's new features like plugins, as well as proving the functionality of our mount connectivity, primary camera, and our plate solver. After we complete the polar alignment process, I'll move on to initial guiding setup with PhD2. Things like calibration and the guiding assistant will be in this part of the video. And finally, we'll take a 2-minute guided image, and this is where we'll end today's video. There's certainly a lot more you can do, and in many cases, I do have videos for those other things. Things like downloading and installing my shared advanced sequences, configuring filter offsets, using plugins like Hocus Focus, Remote Copy, Orbitals, the Web Session History Viewer, and even using my Patriot Astro End of Night script. Understanding the capabilities of Nina's manual rotator and manual filter wheel, Just way too much to mention and way too much to cover in one day. Before anyone complains or gets confused, I will be speeding up portions of this video to save us time. You don't need to watch real-time patching, installations, and autofocus runs. I know some of you will think the install portion moves along too quickly, but it really is the only way to make this video useful to the larger majority. Please feel free to use the pause button whenever needed if you're trying to follow along while you build your own system in real time. If you end up finding this video helpful or think it may be helpful to others, please click the like button, subscribe to the channel, and share it on other platforms. As a quick disclaimer, I am an affiliate of several online stores. This includes Amazon, Agena Astro, and a couple others. If you do plan on making a purchase at some point, please consider using some of these links in my video descriptions or the ones often found in other content creators you follow online as well. I could talk all day, and in this video I probably will. So let's just jump in and get started. The first part of my process assumes you're logged in and looking at your desktop monitor. You're likely using a local monitor or TV via HDMI, a keyboard, and a mouse. Notice I'm using Windows 11 since that's what most systems are shipping with as of the release of this video. But if you're using Windows 10, everything here will work in both Windows 10 or 11, and the steps should be very, very similar. I'm using my Melee Quieter 3 MiniPC and have just reinstalled the Windows 11 operating system onto a new NVMe SSD so I get the best performance possible. As I mentioned earlier, you can use whatever you have since the specific model MiniPC and SSD are not required for any of what we do in the video today. Before we take any steps though, a suggestion. Don't have any of your equipment connected to your system yet. No cameras, mounts, nothing. If you have a USB hub attached, that's okay, but no devices. As a matter of fact, we don't even need to be near our equipment for the first part of the Windows setup and configuration. You can do this right at your desk or kitchen table if you like. You will need internet connectivity, but this can be done from inside the house. Daytime, nighttime, rainy day, it doesn't matter. Get comfortable and take your time to do it right. Okay, first, make sure you're connected to the internet. I'm using Wi-Fi to my Patriot Astro home wireless network, but this could be wired Ethernet if you prefer. Right-click the clock at the bottom right and select Adjust Date and Time. If your time is wrong, and mine is off by a couple hours here, adjust your time zone or sync it to get it right. I'll set mine to the correct time zone for my location. Perfect, the time's finally accurate. Staying in Settings, click System and notice the system name. We'll change that in a minute. Scroll down to the About option. Verify the hardware and device specifications and the Windows version info as well. Up top, click Rename PC. Make this something useful. I like to use at least the mount in the name, but I'll use the mount and mini PC type, so HEQ-Q3. I'll restart later since we have some Windows patching to do still, and I can save myself at least one of the reboots by waiting. Speaking of that, click Windows Update down here. Go ahead and complete all the updates. This likely takes some time and a couple reboots. Go back into Settings and Windows Update after each reboot until it finally says you're up to date. That was definitely not real time right here. Now that we're up to date, click Advanced Options, then Active Hours. Set these manually. This will ensure a Windows Update install and reboot is far less likely to occur during our overnight imaging sessions. I like to set mine to something like 6 p.m. to 9 a.m. as the active hours for my Astro MiniPC systems. Once that's set, click Apps so we can install .NET 3.5, which will be required for the ASCOM platform installer later. You can do it later, but I know it's always needed, so I just get it out of the way early on while I'm already in here. In Apps, click Optional Features, then scroll down to the bottom of the list and click More Windows Features. Select .NET 3.5 and click OK. Tell it to let Windows Update download the files for you. The download and install will complete, and you can click Close at the end. Now let's check the power settings configuration by clicking on System, then Power. I like to change this from the default of Balanced to Performance to make sure everything is continually allotted the power it needs to perform. Notice it says it will never sleep and the screen will never turn off. This is perfect since we likely won't have a screen attached to this mini PC anyway, and we'll just remote control this box. If you're using a laptop or desktop, you can configure yours differently. Okay, we can finally close settings, for now anyway. Here is when I like to do a couple quick installs of any extra non-Astro software I typically have on my systems. You don't have to think of all the extras right now. I'm going to install Google Chrome as the browser, Adobe Acrobat Reader for PDFs, Notepad++ as my text editor, and also an antivirus security suite. We don't need to argue about Google Chrome versus Microsoft Edge or any of the other apps I'm choosing. Feel free to use the apps you are comfortable with. In my case, Microsoft burned the web browser bridge a long time ago. Since I'm installing apps, I also usually take some time here to clean up the desktop and taskbar a bit before I start adding all of my Astro-related software. You can right-click and unpin some of the items like Microsoft Store and Microsoft Edge so they aren't in your way if you like. You can also do some more cleanup and customization within Settings. Once back in Settings, click Personalization, then I'll go to Background. I'll change it from Picture to Solid Color and select something dark so it doesn't affect my eyes at night. Then I'll click Colors and select Dark Mode. Great, this is going to be much better for overnight use. I want to remove even more junk, so I need to click Taskbar here within the Settings app. And this is how you remove some of those items that won't unpin, like chat and widgets. Nothing is ever easy. Alright, so now we can set up this system for remote connections using Windows Remote Desktop, often referred to as RDP. Click System, then Remote Desktop. Toggle it to on and confirm the changes. The default configuration should be fine for us, since by default the account you're using right now on the Quieter 3 will have access via RDP, so we should be okay without any additional changes. But if you want to use another account, you need to assign it rights to do that. Okay, let's close Settings. I'm going to reboot this system to simulate a freshly powered up system, but you may need to shut it down and carry it over to your mount at this point. Do not connect any USB cables yet though, trust me on this. But even still, do get it to a location close enough to connect the cables when we're finally ready. This is the laptop I use to remote control my systems. I placed a blue rim around the screen so you know that it's a different system and not the Quieter 3 MiniPC. I need to be here to set up the client side of the remote control session. I'm going to access my system via remote control during the next part of the process because I need to get the MiniPC at least close enough to the mount cameras and other Astro hardware I'm about to install. I can sit at my desk for a bit while using this laptop while I do that though. Notice my laptop is running Windows 10. It doesn't need to be the same operating system as the remote PC for the RDP connection to work. It can't even be a Mac with the remote desktop client installed. Before I configure the remote connection though, I like to lock in my remote MiniPC IP address with a DHCP reservation from my home router. In my case, I use an Eero Wi-Fi mesh networking system so that I can place multiple Wi-Fi access points around the house and get coverage where I need it. Each of these Eero devices also has 2 Ethernet ports, so I can even use Ethernet when I'm nearby. Today I'm using Wi-Fi with this MiniPC, and I want to make sure that the IP address is always the same so I can easily connect to it day after day. Your process will be a little bit different depending on your home networking solution. But to figure out how to do this, Google your product name along with DHCP reservation, and you should quickly sort out how to do it. For me, my Eero app on the phone does it pretty easily. First, I'll make sure the MiniPC connected to my Patriot Astro Wi-Fi after the reboot. And yep, there it is. I can see it's currently using 192.168.4.60. I'll go into Settings, Network Settings, Reservations, and add this as an IP reservation. This way, it will always be at that IP address. Now let's make this a little easier still. On this laptop, the one that I use to connect to the remote MiniPCs, I'm going to use Notepad++ and run it as an administrator. You could use TextEdit or whatever you prefer. Once the app is running, open up C:\Windows System32 Drivers etc Hosts, and yes, you need to be an admin for this to work. You can see I already have a whole bunch of entries in here. The point of this file is to map IP addresses to names, and I want to add the new MiniPC name here. I'll add it at the bottom of the file by typing the IP address, then pressing Tab, and then typing the computer name, which I want to be HEQ5-Q3. Once in place, I'll save the file. To test it, I'll open a command prompt window by searching for CMD and pressing Enter. Here I'll type ping HEQ5-Q3 and press Enter. And yep, we're getting responses and reaching it via name, which was mapped to the correct IP address. Perfect. Now, on my laptop, I'll search for the remote desktop client. The file name for that is MSTSC, but you can also search for remote desktop connection if you prefer. Let's open that app. Enter the computer name of what you'd like to remote control. Click Show Options, enter the username you created on the MiniPC, I used Astro, And also click Allow me to save credentials. This will make it easier to connect later. Feel free to go back through the other tabs if you like, but I won't make any other changes today. Click Save As and save the connection file. I keep all of mine in a specific Documents folder. Then I create shortcuts to the most used ones on my desktop of this laptop. I use the system name as the file name. Once saved, you can create the shortcut pretty easily. Open the file manager to the location you save the file. Right-click the file, then click Send File to Desktop Create Shortcut. Once I see it on the desktop, I'll rename the entry to remove all the extra text and then close the file manager. So now I have a shortcut on the desktop and I can close this application window. Let's double-click the new shortcut and see if it works. Almost definitely on your first connection, it will tell you the system is unknown. Click Don't Ask Me Again and click Connect. You'll be prompted for a password. Notice it's using my laptop device name, Astro PC, and not the remote system name of HEQ5Q3. And this is a problem and where lots of people get lost. Click More Choices, then click Use a Different Account. You might be able to get some leeway from Windows if you use the same user account name and password on all of your systems, but follow along and I'll get you in. When prompted, use the account you created on the MiniPC, which for me is Astro, and then enter the password for that account. I'll also check Remember Me, then click OK to connect. You'll be prompted that the certificate doesn't match. Click Don't Ask Me Again, then click Yes. And yes, before you ask, this will all get a lot easier moving forward. All right, we're in. Here's the MiniPC desktop. To prove this connection will be much easier next time, click the Windows icon, then your username, then click Sign Out to log you out of the remote system and disconnect the RDP session. Here we are back on my Windows 10 laptop, so I just double-click the RDP icon again. No questions, no authentication prompt, we're in. Much, much easier moving forward. That wraps up most of our Windows setup, so we can now move on to the Astro portion of the installation and configuration. Okay, how's it going? We're about to jump into Astro hardware and software installation. The good news is that this next section can still be done indoors and even on a rainy day. Remember, please do not connect any Astro equipment until instructed to do so by me. It will make your life easier if you do it one piece at a time so you don't get lost in a sea of COM ports. You can be directly connected to your MiniPC with a monitor, keyboard, and mouse as long as it's close enough to the Astro equipment to make connections when instructed. For me, I'll continue how I left off, working from a nearby Windows 10 laptop and remote controlling the MiniPC sitting near my equipment. I'm indoors and it's daytime. I do have a USB hub connected to my MiniPC, but that's just to address the USB 3 port count I require. Nothing else is plugged into that device other than power. Now, one last thing before we get back to the remote control session, and I mentioned this towards the beginning of the video. I am downloading and installing software for my own mix of hardware. I'll take you through my process so that you can be successful too, but you need to get the software required for your own equipment. I'll speed up the downloads and installs and only slow down the video to talk through the process and what I'm doing at each step. If you're following along during your own build, you will definitely need to pause the video here and there to get what you need. Ready? Let's get back to it. Finally, let's get into the heart of the MiniPC Astro install. I like to keep things organized and I like to have a plan. Let me show you what I do for my own installs. I'll open File Manager and go to my Documents folder. Here I've already created a simple folder hierarchy to store all of the installers I'll use. These can be handy later if I ever need to reinstall or happen to be somewhere where someone else needs a copy. In this case though, it'll just keep my setup process organized. My top level folder is SW Installers for my general software installers. I've mentioned previously in other videos that occasionally I'll use the leading underscore character in my folder and file names to make sure they sort to the top of a list alphabetically. Inside here, I have two more folders for Astro installs and other installs. You can see I've already moved the items I already installed on this MiniPC to the other installs folder, like Chrome, Notepad++, and my security software. We're going to spend some time now on the Astro installs folder. And yep, more folders. Here I have folders for hardware installs and software apps related to the Astro stuff I'll be using on this Quieter 3 system. I also have an Astro info text file that has some pre-install info I like to have handy. Okay, before I click into any more folders, I'll be sure to make this easy for you and share this folder and file structure with everyone on my Patriot Astro website. Go there and click More, then click MiniPC Install Process. There you'll find some basic guidance and a copy of this video, but more importantly up top, a zip file that includes this folder hierarchy and a sample Astro info file. Just download it and extract it to your system so you can follow along more easily. And please remember, you can follow my process without using this folder structure. It helps me to be a bit more organized, but you may not need or want it, and that's fine. Do whatever you prefer. Okay, let's look at the hardware drivers folder. I've got several folders in here based on the order I want to install and connect everything. Based on my own hardware to be controlled by this mini PC, I'll download whatever is needed and place it into these folders. If or when you download this folder structure from my website, you'll just get the folders, no installers. You need to download what you need for your own hardware combination, but I'll try to take you through some of that today. Notice that I have ASCOM platform first, then my mount, cameras, focuser, filter wheel, and any other accessories. If you don't have any of this, it's okay, just leave those folders empty. Back to Astro install and into software apps. I have a similar numbered structure, but for software tools. First Nina for deep space imaging, then SharpCap for my planetary, lunar, and solar imaging, ASTAP for plate solving, PhD2 for guiding, and then any other extras. Again, only download and install what you need. I'll drag this over to the right so I can open a downloads folder on the left. As we download various software from the internet, I'll move it from the downloads into the correct folder within the hierarchy on the right. And it's finally time to get some software. The first thing we need is ASCOM platform. Go online and download the latest version, which as of this video is 6.6. And notice it requires .NET 3.5, which we already installed earlier. This downloaded fairly fast for me, so I'll go ahead and drag it over to the final location. The next software you need is for your mount. My mount is an Orion Sirius EQG, which is basically a Skywatcher style HEQ5 mount. Depending on your mount, you can click here on the ASCOM site on drivers and downloads, then on the telescope mount menu option. For these Skywatcher style mounts, a lot of people are starting to move over to the Green Swamp server these days, but I'm going to keep working with EQMOD since it's how I have everything else I use configured today. I'll use the link from this page, but could have searched for it directly if I wanted. Remember, you need to get the mount software required to control your own equipment. If you're not sure, try asking in the comments of this video or on any of the several forums out there. And also, please, anyone that has experience, check the video comments below so you can help some of these people out. For me, once at the EQMOD site, I'll click Downloads, then EQ ASCOM, then download the latest version, which today is V200W. When that download completes, I'll move it into the Mounts folder. Don't forget, sometimes you need more than one piece of software. In my case with this mount, I need to use an EQ Direct cable. I built my own cable, but you can buy these off the shelf if you like. Either way, I'll need a serial USB driver for the cable to work. As a recommendation for a cable in this specific case and this mount, I like the cables from Shoestring Astronomy. And as a nice side note, he has an easy link in the download section of his site to get the USB serial driver I need. And this is a very common driver for this type of access. I'll get the latest setup executable and move it into the mount folder as well. Let's clean away some of these browser tabs because next is camera software. I'm using ZWO cameras for both the primary imaging camera and my guide camera. Go to your vendor download site, as I am here, and get what you need. For ZWO cameras, I'll download the Windows native driver, and I can see here that as luck would have it, since I'm also using a ZWO EAF focuser and a ZWO EFW filter wheel, it appears I shouldn't need additional software for those components for Windows since they're native USB HID devices. I'm going to scroll down though and also get the ASCOM driver install for the camera EAF and EFW because you never know when some other software you may want to use would require ASCOM drivers over the Windows native drivers. After these downloads complete, I'll put them in the camera section, even though the ASCOM ZWO installer will cover me for a few other components as well. Okay, now on to the focuser. I already mentioned I'm using a ZWO EAF, and I already downloaded the ZWO ASCOM driver bundle, but you may have noticed in some of the other videos that I have another telescope locked to the bottom of this rolling base I built. I occasionally use that other telescope for solar imaging when I want to get a bit closer to the sun, and it uses a Pegasus Astro Focus Cube 2 focuser. So I'll go ahead and grab that software too for whenever I want to use that later on. Remember, at this point, we're trying to get everything we need. As it turns out, I'm sort of lucky in this case as well because I happen to use a Pegasus Astro Falcon Rotator on the telescope I'm configuring today. And just like many other vendors, Pegasus Astro has gone over to a unified driver installation tool. As a result, by downloading their Unity software installer for the Focus Cube 2, I'm also getting the Falcon Rotator driver I needed as well. And just like everything else, let's drag it over to where it belongs. Okay, in my case, the filter wheel I can skip because I already downloaded the unified driver from ZWO earlier. For accessories, I'll get whatever else we missed from a hardware perspective. I already got my Falcon Rotator covered, but this could include things like flat panels or really anything else that uses drivers and software that you need to run. I'll use this time to get my PoleMaster polar alignment camera software and drivers from QHYCCD. This is a perfect example of making sure you get everything you need. Here, I need the PoleMaster Windows system driver and the Windows stable software. Sometimes you need one piece of software, sometimes 2 downloads, and sometimes 3. It really depends on your hardware vendor, and if they have native OS drivers, application software, and maybe even separate ASCOM drivers. And of course, when done, move it all over to accessories. Well, that should be it for my software driver related downloads. Now let's get the software apps we need. First on my list is Nina. The latest stable release as of this video is version 2.0. I'll get that first. Now with Nina, we ideally want to get a couple other items from the bottom of the downloads page. We need the Sky Atlas image repository and also the offline SkyMap cache. These are 2 big files, so they can take a bit of time to download. Once all 3 Nina downloads complete, drag them into the Nina folder. Next, I like to get SharpCap for my lunar, planetary, and solar imaging. You may want other software, and that's perfectly fine. I'll go to the SharpCap page and download the 64-bit version of SharpCap 4, which is the latest available today. And like everything else, move it over. Next, I'm going to get ASTAP for plate solving. There are other alternatives, but this is by far the fastest plate solving solution in my experience. When getting ASTAP, we need to download 2 items. First, the 64-bit program, then you also need a star database. For most people, I recommend getting the H18 large star database. If using short focal lengths, you can instead get the H17 version, but H18 should work in both cases and be a bit more flexible moving forward if you change your scope later down the road. The database download will take a bit as it's fairly large, but when done, you guessed it, move them over. Now guiding. We can go download the latest version of PhD2. If not guiding, you can skip this piece, of course. The PhD2 webpage recommends running the latest development snapshot. Some of you may not be comfortable running a development build, but since they are the ones developing the product and they have the best understanding of how they code and patch their builds, I'm going to go with their advice. I'll click on the linked text, then download the current development snapshot for Windows and move it over. You want anything else? Get it now or later. It's up to you. I'll likely install something like Stellarium later, but I'm not in a rush for that today. Okay, deep breath. We downloaded a lot of software and drivers and haven't installed a single thing yet, but that's okay. We have a plan and we're getting ready to do it the right way. Now I want to make sure you're ready for the installs. You need to have some information at your fingertips so you don't get hung up at any point, and this is where that Astro Info text file comes from. Let's take a look. These are things I need along the way. What mount are you using in any details? Your guiding camera and guide scope, your telescope or OTA camera combination, filter wheel and filter order, focuser, other accessories, and even location data for your viewing site or sites. This will all come up at one point or another. You can even use this file prior to the download process beginning to make sure you download everything you need. I'll try to keep it open for the most part during the install, but I'll tuck it away off to the side. For installs, we start with the hardware drivers, starting at number 1 and progressing from there, always starting with ASCOM platform first. Locate the installer in the folder and double-click to start it. Okay, for this one, I noticed a weird issue on Windows 11, and this may be fixed by the time you do your own installation. But for me, it says it needs to install the x86 and x64 2019 Visual Studio versions, but in mid-install it fails. In my experience, and I've done this 4 times now on Windows 11, just restart the installer and it'll proceed without issue. When ASCOM platform completes, we can move on to folder 2 of the hardware drivers, which is the mount. In my case, for my mount, I'll start by installing EQASCOM. The default install is fine. It completes pretty fast, and I can follow it with the USB serial drivers I need for my EQ Direct cable. This also installs fairly quickly. Okay, now that I have my mount software installed, I can test this component. I like to test things as I go along for devices where I can do that. I don't worry too much about cameras, but mounts are just a different breed of hardware, and the connectivity can be challenging at times. Before I test my mount connectivity, I want to open the Windows Device Manager. This will allow me to check on the devices as I connect to them one by one via USB, and in this case for my mount, it'll let me know what COM port it grabbed. So search for Device Manager and open it up. Notice I don't have any COM ports listed yet. Let me plug in the EQ Direct USB cable into my USB hub that's connected to my Quieter 3, and there we go. Almost immediately I can see it show up as COM3. Now I can click on the Windows icon and find the EQMOD folder in the application list and open Setup EQ ASCOM. If you're not using a Skywatcher style mount and EQMOD, use whatever comes with your mount. This is whatever would allow you to test your connectivity. The real point here is that we should be installing and testing one piece of equipment at a time whenever possible. I can set up my EQMOD port info now. That I remember is COM3. I'll also set 2001 and 9600 as the baud rate. Depending on your cable and mount, if using EQ ASCOM, you can push it to a much higher baud rate like I do with my EQ6R Pro mount. There are a couple other things I'll set while I'm here, and your mount may be similar to this, but for me, I need to make sure I'm setting ASCOM pulse guiding. I'm going to allow site writes as a suggestion by the Nina documentation. Nina also wants me to set time as JNOW. I can also set my mount location, latitude, longitude, and elevation. This particular app lets me save multiple locations for ease of use. I'll label this one home and click the save button. If I had other common viewing locations, I could set and save them now too, but I can always add those later if I pack up and go somewhere. And lastly, I'll click OK. Now I'll go back to the EQMOD application folder and click EQ ASCOM Run to see if we can connect. Perfect. I'll test parking and some slews. Connected and working. With EQ ASCOM, I have some other settings I can configure once connected. Click here to get into the setup and it will expand to the right. Nina and PhD2 both have various recommendations for this particular mount's connectivity options. The user interface should be changed to dialogue based as per Nina. There are some other things we'll see later, but they aren't available just yet. Sometimes during this process, you're going to need a break. I took one and also performed a quick mini PC reboot here while I did. But you don't need to do that. I just wanted to prove that you don't need to do this all at once. Get something working and walk away. It's fine. Take your time. All right, let's dig back in. Okay, back to the folders, and next are the camera installers. And remember, they aren't yet connected to USB. First, for ZWO, I'll do the native Windows driver install. Then once that completes, I'll run the ASCOM driver installer. This ASCOM installer covers the cameras and my filter wheel plus my focuser, since they're all ZWO products. I'll also add the ASI mount because you never know. I definitely will never use ST4 connectivity, so no need for those. Okay, raise your hand if you're asking why I don't use the ASI Air since I use so much ZWO hardware. And it's a valid question, and maybe one day if they can run Nina, I will. But right now I use multiple telescope rigs and not everything is ZWO across the board. So the consistency for me is Nina. And with all of the functionality and extensibility within Nina, I can't see using anything else. But before I get attacked, I 100% love the idea of the ASI Air and see the need for it in the market. It's just not for me, at least today. All right, camera software should be ready now, but just as a quick confirmation, I can open Windows Device Manager and then connect each camera to USB one at a time. First the 2600mm, and there it is. And now I'll connect the 290mm mini guide camera, and there we are. Now we can move on to the focuser. For day-to-day use of this scope, I'm using a ZWO EAF, and that's a native Windows USB HID device. Plus, I already installed the ASCOM drivers a minute ago, along with the ZWO camera ASCOM driver package. But if you recall, I also want to add a Pegasus Astro Focus Cube 2 driver to this system at some point for when I change out my telescope for that other OTA I occasionally use for solar. To get that software in place, I would need to install the Pegasus Astro Unity installer. I'm going to hold off on that software for a bit though, since I'm not connecting that focuser today. But since we're in the focuser section of my install process right now, I'll go ahead and connect the USB cable to my ZWO EAF. I could look in the HID section of the device manager if I wanted to see it, by the way. Also, in case you're curious, HID is Human Interface Device. This is typically in Windows for things like keyboards and mice, but also some game controllers and I guess focusers too. If you really want to know which ones in this HID list of device manager are the ZWO equipment, the code you're looking for is 03C3. That's what ZWO happens to use. Now I can move on to folder 5, the filter wheel. And that for me is also a HID device and already installed by the ZWO ASCOM driver package. So I'll connect that USB cable as well, but there's nothing else for me to install to get it working. Make sure you do your own install for your own device. And so finally, I go over to number 6, which I label as accessories, or sort of a catch-all for other stuff you may have. Here we'll take care of my PullMaster installation. First the driver, then the Windows software. After the install, I can connect it to USB 2. And if you're interested, that shows up in here in a folder called Astro Imaging Equipment, which makes all of my other gear feel a bit left out. To test the PullMaster, I'll run the software we just installed. Connect to the camera and remove the cover to see that we have a light level change. This is daytime, so this test is good enough for me right now to prove it's connected. The last accessory I need to install today is my Falcon Rotator. This happens to be by Pegasus Astro and uses the Unity installer we bypassed earlier, so now's the time to install that one. You didn't ask yet, but I know you want a video on that piece of equipment too. After install, I'll run the application and connect the Rotator USB interface. And there we go, connected as I expected. I'll close this for now, but just out of curiosity, let's go back and look at the device manager one more time. Look at that, the Rotator is showing up as using COM4. Good to know. And this is why you install and connect one piece at a time. Okay, all the hardware is installed and connected. Time to get the software apps running and connecting to everything. I like to do some more housekeeping first though. I'll delete some desktop icons that were created along the way. Shortcuts I don't need all the time, don't need to be here. Now onto software app number 1, and that's Nina. If you recall, we downloaded 3 items for Nina: the application, the Sky Atlas, and the framing cache. First we install the Nina application, then launch it. Let's do some basic Nina config right now. I have some other videos on this, and I'm sure I'll have more down the road, but I need to make sure we get some of this set up in place now before we get too far along. First, name your profile. I like to name it after my OTA mountain camera. Set your language, and since Nina 2.0 is now the official release, we can leave this as release version. Now here, you see the Sky Atlas image folder field is blank. We need to install this and then tell Nina where we put it. If we go back to the file manager, we can see inside this zip file is just a whole bunch of image files. Just copy the Sky Atlas image repository folder from inside the zip file and put it somewhere on your system. I like to put it in my documents folder. This extraction will take a while, so let's move on to the framing cache in parallel. Back into the Nina installer folder, we can go into the Framing Assistant cache zip file. Again, an enormous amount of files. You might be asking why we need both sets of files, but don't worry, I'll show you soon. So just like with the Sky Atlas, we can copy the folder inside this zip file, but this needs to go to a very specific location on your computer. But where? Well, find or open another file manager window. Click up top and type %localappdata % and press enter. This is a hidden Windows folder location. Locate the Nina folder and double click it. You want to paste the Framing Assistant cache folder in here right on top of the one that already exists. I'll speed this up, but this next part is important. When the copy of the Framing Assistant cache completes, it'll ask you if you want to overwrite the cache info XML file. Click replace the file in the destination. Then wait for the Sky Atlas file copy to also complete if it hasn't done so already. Now we can come back into Nina and I can show you what this was all about. First, the Sky Atlas. To show you this in Nina, I'll go to the Sky Atlas option over to the left. Once here, I'll click search. I get lots of results, but notice everything says no image available. But if I come back to options and tell Nina the Sky Atlas image folder location is in my documents folder like this here, then go back and do another search, now we have an image for each result. Search for something specific like M101, and we can see it. It really isn't 100% required for Nina to work, and that's why it's broken out as a separate large download. But I still can't imagine you not wanting this. If you're still paying for data by the megabyte over a satellite link in Antarctica, maybe you want to avoid this, but for everyone else, go get it. And also keep it handy for the next install. No need to download it more than one time, just share it between systems. Okay, now over to framing by clicking here. The default framing lookup repository is over the internet using the Hips to Fit Sky survey, But you aren't always online with your system, and it can take a bit of time over a slow link to get these images one by one in the middle of nowhere. So instead, we can preload the entire sky using the Framing Assistant cache we just downloaded. Let's change the image's source here to Offline Sky Map and click Load Image. This is going to load these coordinates here with a 3-degree field of view. It will load a view from the cache we just installed. I can scroll out with my mouse wheel and see that Nina is dynamically building resized cache images of the entire sky based on our recent download. This cache build is a one-time task, so I like to zoom out and get it out of the way now. We downloaded one image size and Nina builds the rest for us, which actually kept our download a bit more manageable, believe it or not. Now we can drag around and look anywhere we like or search for a specific object like M101 again. And now you know what those 2 additional large Nina downloads were for. Back to the Options Profiles page. Next, I like to set the color scheme. I like to use a darker primary scheme for nighttime use, but you can use or customize what you like. I often then set the alternative scheme to something lighter. You can toggle between the two here with this button. As a quick note, if you ever need to run 2 copies of Nina simultaneously for running 2 sets of gear off the same computer at the same time, which is way out of scope for this video, the first Nina instance will use the primary scheme and the second instance will run the alternative UI scheme. This way you can easily tell the 2 running app instances apart. While still in Options, let's click the Equipment Options icon. Here we can set our telescope name, focal length, and focal ratio. The focal length will be used in a couple places, but for plate solving it will be critical to be accurate. This should be the actual focal length of your combined optics. Down in the bottom right is where you can set up your planetarium software linkage. I'll be using Stellarium at some point, so I'll make that change now. Set it to whatever you plan on using, and if you aren't going to use any of them, just leave it as the default. Now, still under Options, we can go down the list of icons and click Autofocus, then Dome 2 just to see what they look like. But we aren't ready for any of this just yet. Now click the Imaging icon. There's a lot going on here, and you may want to watch my Nina profile setup video later, but right now what we care about is the image file path and image file pattern. By default, imaging sessions will be saved in the root of your Documents Nina folder, and that may be okay. If you installed the high-speed NVMe drive, and that happens to be your D drive though, you want to take advantage of that by changing this path. For me, since I'm using an NVMe SSD and have Windows installed to that as the C drive, I could leave this alone, but instead I want to change it by creating a Nina_sessions folder inside that Nina location. This will keep my imaging sessions in their own Nina subfolder that'll be a little bit easier to use by things like the Remote Copy plugin and my Patriot Astro End of Night script. Ultimately, this is anywhere you want to save files, so this could even be a local USB drive. After setting the path, we can look at the file pattern. The pattern controls naming and creation of directories, subdirectories, and files. Notice there's a bunch of words in here with $signs on both sides. This lets us know that these keywords are variables that we can use to dynamically name our elements. Below the file pattern is a preview that gives us an example of what the pattern we defined can provide. There are lots of variables you can use. Some you may want in your directory names, others in your file names, and still some you won't need at all. We won't be saving files yet in this video, so you can come back here later when you're ready to save files. And the final icon in Options is plate solving, but we'll come back here soon too. Right now though, we need to focus on getting our equipment connected to Nina. Click Equipment in the upper left corner. There are icons for each piece of equipment Nina can control. We'll start at the top and work our way down the list for the most part. Up top it says there's no camera to connect to within the Nina profile. If I click the drop-down though, I can see what's currently available. If you don't see your camera here, make sure it's connected to the computer and then click the refresh icon to let Nina discover any new devices. Still don't see it? Double check your software and driver install for that equipment. I can see both of my native drivers for my ZWO cameras and also the ASCOM ASI camera connections. I'll be using the native Windows driver because it gives me the best capability support for these cameras. My primary imaging camera for this telescope is a 2600 mm, so I'll click on that one. After selecting it, I'll click on the Connect icon. At the bottom right, a Nina pop-up says the camera is now connected, and we see all sorts of information. What is presented here is camera capability specific, so you may see more or less than I do. This camera has a built-in dew heater that I can manually toggle on and off here. It supports a built-in cooler capability and reporting. It imported several camera-specific data points like sensor size, min and max exposure lengths, binning capabilities, pixel size, and current gain and offset values. Down here near the temperature and cooler power graph, it lets me modify the default gain, offset, and USB limit for this camera. I'll change some of that here now. Changing it here means I won't have to specify it manually on every imaging command used throughout a session. Before we leave the camera equipment page, and since it's so hot outside today and I'm doing all of this in the middle of the day, I'll set cooling to -5°C and enable it for the camera. Again, just another verification of functionality. Now with the camera connected and cooling, let's move down the list to the filter wheel. I have a ZWO EAF. Again, if you don't see yours, check the connections and software driver install. As a quick side note, if you don't have an electronic filter wheel but do swap filters from time to time, maybe using a filter drawer, manual swapping, or a manual filter wheel, you may want to consider Nina's manual filter wheel device. If you want more info on that, search my videos for that topic. I'll place links to that and some others in the video description, of course. I connected my filter wheel and we can see it's working, but the filters are just labeled as slot numbers starting at 0 and moving through 6. To customize this right away, since it's finally connected to Nina, I can come back to Options Autofocus. Notice the filter names were imported here and match what we saw on the equipment page. Here in the Options section, though, we can edit the names by double-clicking them one at a time. If you remember from my text file, I recorded the filter list order in that document. Now if I go back to Equipment Filter Wheel, we can see the names we expect. And like many other elements in Nina, this info can also show up in numerous other locations, including directory and file naming saved during imaging sessions. I can even test changing a filter right from here. Moving down the list of equipment, the next item is the focuser. My focuser didn't have a Windows driver to install, but used ASCOM instead, so that's what I'll search for here. I'll show you something else before I connect to it, but after selecting it, I can click the gear icon to see if there's any customization of the driver that can be done. Only change items if you need to do so. Maybe your focuser motor needs to be reversed, or you want to set the 0 position or step size. It's all controllable by you here. I won't make any changes and just go ahead and connect to it via the ASCOM driver. A quick test by changing the focuser position and clicking Move to make sure I see it rotate. Perfect. Looks like it's working fine. You can also use these buttons at the bottom to move the focuser in and out. This button moves the focuser half of the defined Nina autofocus step size, and the outer buttons move 5 times the defined autofocus step size. Hear what I'm saying though, this is the Nina autofocus step size, not the driver motor step size. For me, in Options Autofocus, that was set as 50. Don't worry about focus just yet though. Next, I need to connect my electronic rotator. This is a really cool device that I'll do a video on some point soon. If you don't have an electronic rotator, and there are so many reasons you may not, like cost and back focus spacing availability, you may still want to look at adding the manual rotator Nina device, and you can watch a video I did on that as well. Once I connect my rotator to Nina, I can test its movement. And on we go to the mount, which Nina labels as telescope. Because of how I connected my mount earlier, I'll select the EQMOD ASCOM HEQ5 driver here. Before connecting, I'll click the gears and double check the settings, and you can see it remembered everything we defined. So I close it and click connect. It initially prompts me to tell me that the telescope has sight settings, but Nina's are different, and that's because I never set my location in Nina's profile earlier. In this case, I'll tell it to sync the location data from the telescope to Nina. Now that Nina is connected, EQ ASCOM will show me some other settings such as ASCOM pulse guide settings. I need to adjust these, but we'll show you this again during the PhD2 guiding installation. Just know that as per both Nina and PhD2, you want to raise these two sliders quite a bit, maybe to 0.8, but at least 0.5. We can even test out some additional functionality by using the unpark and park function from within Nina to see it reflected in the EQMOD interface. At this point, you can continue to go on with Nina, but I also promised to get SharpCap connected to some of this primary hardware, so I'm going to disconnect each piece of hardware from Nina, then close it and move on in our process to the SharpCap installation and configuration. Back to our software folder, we can run the SharpCap installer we downloaded earlier, then launch the application. To assign our hardware devices to SharpCap, we need to go to File, then SharpCap Settings. Then click the Hardware tab. Also, don't forget the Saving tab if you need to change the save path to your NVMe SSD drive. On the Hardware tab, I can assign a focuser, filter wheel, mount, and even a rotator. These will all connect automatically whenever I select a camera in the application interface. One by one, I can go through and select each device much like what I did in Nina. I can even click Properties and make driver level changes as needed. For my filter wheel, I'll change the ASCOM filter name list to match my filter placement. Want more info on filter offsets? I have a video on that too. It's done in Nina, but the calculated offsets will work here or anywhere else. I'll also add my rotator while here too. Okay, after saving this, all I need to do is go to Cameras and select a camera I want to use with SharpCap. As soon as I do that, the system will attempt to connect the camera and all of those other devices as well. And there we go. Scrolling down on the right in my scope control section, I can see my mount, focuser, filter wheel, and filters, plus my rotator. That's it. I can control it all from here now as well. Not much to do in the daytime though, so I'll close it down and get back to our software installs. The next step is to install our plate solver, which is ASTAP. This is a two-part install. Don't forget part 2. First we install the application. This is a quick install. Next we need to install the star database, which for me was H18. This install takes a bit longer. To complete ASTAP configuration in Nina, we need to go back to Nina. You don't need to connect any hardware right now. Just go to Options, Plate Solving, and make sure ASTAP is selected up top, and then locate it at the list in the bottom and tell Nina where the application was installed. For most of you, this will be C Program Files, ASTAP, astap.exe. I don't have a need to modify any of these other settings for my telescopes to work, but if you get any errors while plate solving in Nina, just pay attention to the warnings it provides and follow the recommendations to resolve it. The next install is our PhD2 guiding application. I'm going to make a suggestion here, especially for those of you that use the same brand camera for both imaging and guiding. Disconnect your primary imaging camera from USB right now before installing PhD2. You'll see why after the install completes. This is a fast install as well. When it opens initially for the first time, it will prompt you with the new profile wizard. Go ahead and select your guide camera from the drop-down. Here I'll select ZWO ASI camera. I'll then tell it to detect the parameters. Notice it detected the pixel size for my guide camera. This is why I disconnected my primary camera. Because they're both ZWO, I had a 50-50 chance of selecting the wrong camera. Not the end of the world, but this makes it easier. I'll set my guide binning at 1 and set my guide scope focal length. I record it over here at 120mm. After clicking Next, it asks me about the mount I want to connect, which we know is the same one for my setup. It will ask about the guide speed. I'll leave the default here at this point. Of course, throughout any of the install, answer based on your own equipment. I can skip the adaptive optics section since I don't have one. Finally, give this profile a name. I, much like Nina, like to use a combination of the camera and mount. I do want to auto restore calibration, and I want it to build a dark library, so I'll be sure to check both of those. And then click Finish. It immediately connects to my equipment and prompts us to build the dark library for this camera. You can set these parameters how you like, but I know I won't go any shorter than a 1-second exposure and likely no longer than 3.5 seconds. And for me, 5 of each is okay. I then enter a library note here and start the process. It will tell me to make sure I have the guide scope covered for this process, and since this is being done in the daytime, I may want to cover up the scope to avoid any light leaks I could have. When it's done, it'll tell me to uncover the scope, but I don't need to do that for this daytime portion of the install. As a side note, I could also connect my rotator here under More Equipment, but since the rotator installation on this telescope doesn't affect the guide scope rotation and only rotates my primary camera, it isn't needed. Now this isn't the case for my rotator on my SCT using an off-axis guider though. In that case I need to tell PhD2 about the rotator, but that we're going to save for another day. Right now in our Astro MiniPC install process, I can disconnect the equipment from PhD2 and close the application. Just like with our ASTAP plate solver, we need to go back into Nina to tell it about PhD2. Back in Nina, under Equipment, Guider, we can select PhD2 from the equipment list and then select the gears icon. Click on the PhD2 path option and find the executable for PhD2. For most of you, that will be C Program Files x86 PhD Guiding to PhD2exe. Then click OK and connect it. Notice it starts the PhD2 application for you and connects the equipment to PhD2. So the mount opens as well. But be careful though. PhD2 started and connected to the mount, but Nina is not yet connected to the mount and will not be until you tell it to make its own connection. We have some options on the Nina Guider page now that PhD2 is connected. You can see the PhD2 profile used to connect and some specific settings around how Nina should use the guider and functions like dithering. I'm not going to go into this today, but it'll be a topic I cover soon in another video. So back to our installation process. The last folder is extras, and I myself don't have anything else I need to install today. You can install planetarium software or other tools and apps, but for me, this is the end of my daytime install process. For now, I can shut the MiniPC down and wait for some clear night skies before I can get into the final testing and validation. I know this video is getting long. Who am I kidding? It is long. But this is a process that takes a while to complete. We're almost there, so stick with me and you'll be up and running soon. For this final part of the Astro MiniPC install, you need some clear dark skies. If you don't run into any issues, it shouldn't take too long, but make sure you have enough time between clouds. If you pay attention to the Windows dates in this video, I had an 11-day gap between what we just covered and what I'm about to show you. Let me set the scene here. My telescope's been rolled outside with the new mini computer at the base. Everything is USB attached, powered up and running. The mount is roughly aligned to north, but not yet polar aligned. I did RDP into the system from my laptop that's nearby and started Nina. I can eventually move into the house, but since I'm not yet polar aligned, plus it's my first run through and this is a new PC and hardware configuration, I'd like to be close by to visually validate operation if needed. Plus, at some point, I need to physically manipulate the azimuth and altitude knobs on the mount during polar alignment. Okay, here we go, approaching the finish line. I'll first show you a fast way to connect your equipment, assuming all of the hardware is still connected via each drop-down, which I can verify this first time by stepping through each icon. It should all connect one after another for us by clicking this button down here. Everything opened and connected as expected. There was an item I mentioned earlier in the video about pulse guide rate for my mount. For this mount and connection method, it's suggested by both Nina and PhD2 that I raise this from 0.1 to at least 0.5, but many people find it works better even higher around 0.8 or 0.9. Today I'll push both RA and DEC to 0.9 and verify the minimum pulse width is the lowest possible setting on the slider, and that DEC backlash here is 0. I've also disabled my mount limits in here, and that's another configuration video for another day. Now you may want to leave this on and set it accordingly, but I don't have a video to help you with that just yet. Okay, the first place I want you to go tonight is Options Autofocus. This is all default settings. What I want you to look at right now is the default autofocus exposure time, the autofocus step size, and the initial offset steps. Now go over to the imaging page so we can validate the functionality of a couple pieces of gear while also working out our basic autofocus settings. Let's first set a manual exposure time of 6 seconds like we saw in the default autofocus configuration. I'll set it to the L or luminance filter and start an exposure. This is actually pretty well focused already. You can see the image statistics over here, and most notably I'm looking at the current overall HFR for this image, which is 3.25. If you want to see what stars are detected and used in this calculation, you can go back to Options Image and enable Annotate Image, then retake another exposure. We can zoom in to see the detection and HFR assigned to specific stars. There is a lot more to this, and watching my Hocus Focus plugin video could help you understand the importance of detection. But for now, we're going to stick with the built-in Nina mechanisms and focus routines to get you started. Notice this image came in at 3.17. I'll turn annotation back off for now. Then back at Imaging, let me click on Focuser. Looks similar to the equipment page controls, but much more accessible to us right here. Notice the current focus position of 26408, and if I click to move it half the autofocus amount, which was 50, it should go up by 25 as expected, right up to 26433. After moving this direction, let's take another exposure and see the new HFR. This time it's 3.30. If I move back 2 times in the other direction, I'll be at 26383 and we can test over there as well. This time the HFR is 3.26. I'll move back to 26408, but the point is here for you to try to get close to focus initially by adjusting your focus and checking the HFR at various focuser positions. Lower is better. Okay, now that we're back where we started, I'll take one more exposure and make note of both the focuser position and HFR value at this position. Now I want to move the focuser far enough to get the HFR to register as 3 to 4 times the in-focus HFR. If I click here to move it 5 times the autofocus step size, which for me by default was 50, so a total of 250 focuser steps. Our last reading previously was 3.19, so 3 times that would be 9.57, and 4 times that would be an HFR of 12.76. We're not looking for accuracy here, just something close. Once the focuser's in position, I'll take in another exposure. Okay, we're at 26658 and we have an HFR of 9.66. That's at the low end of my 3 to 4 times HFR multiple and should be okay. But just to move it a little bit more, I'll add another 50 steps and get it to 26708. Take another image and it increased again, this time to an HFR 11.8, and I'm happy with that. It's right in the middle of what I was looking for. Okay, so time for a little math. Our autofocus routine is set to use 4 initial offset steps. So if I start near focus and move 4 steps to the right, that would be 4 times 50 or 200 total steps. But we found that to get to a 3 to 4 multiple HFR number, I actually had to move a total of 300 focuser steps. This lets us calculate our starting autofocus step size. See, 300 divided by 4 initial offset steps is 75. That is our new autofocus step size. You need to run through this procedure on your own system. Every system's different. You just saw how easy the first part was. Get close to focus and note the focuser position and HFR at that point. Now move in one direction until your HFR is 3 to 4 times that number while it was in focus. The total amount of focuser steps you move divided by your initial offset steps is your autofocus step size. Mine is 75, but yours could be 5 or 75 or 500. It depends on your focuser, optics, and some other stuff too. I'll change my step size here in Options Autofocus and then come back to the imaging page. A couple other quick tips here. If you aren't getting values at the edge, or when you look at annotations you don't see many stars, you may need to increase your autofocus exposure time. This can happen with long focal length scopes and slow optics, or in cases where you're using a filter that's blocking a lot of light. I have a lot more detail on this entire process in my Hocus Focus plugin video. Alright, we set up some base values in our Nina autofocus configuration, but before we test it, we need to put the scope back to near focus as a starting point. So I'll manually set it back to 26408 and take a picture to validate it. You might ask, why would I take another picture to validate it since I just took an image at this position? Well, it's a best practice. You could run into a situation where your focuser isn't connected right and is slipping, and while you might expect focus, you may not get it. So I test, and at this point I do have 6 seconds to spare. All of the time I take now will save me time down the road. And look, you may have expected something closer to 3.2, but I got 3.69, so is it slippage? Maybe, but wait a couple minutes and I'll show you something else to look for. Now I'm going to enable the autofocus tool panel. That's up here, just click on it to open it up. Okay, new Nina people, let me show you something real quick about this interface. This new panel opened up over here, but I want it somewhere else. And if I click and hold the mouse button on the top bar here, I can drag it to a new position. I'll pause the video here. I actually have 10 options for window placement from this point. Even some of the longer term Nina people may disagree with me until they give it some thought, but trust me, just wait a second. In the middle of the screen near my mouse pointer, I can release this window on any of these 5 floating buttons. If I release it here, it will become a tabbed window in this location, along with whatever else is already here or tabbed here. If I drop it on the right one, it will split this larger square into 2 sections and put my autofocus window to the right of whatever was already in this space. And the opposite will happen if I drop it on the left side. And similarly, I can split the box top to bottom by dropping out on either of those 2 spaces. There are also these 4 other locations on screen off at the edges. Dropping it on one of these places will move all of the other sections either left or right or up or down and make room for the new panel. Okay, so that's 5 options in the middle plus 4 at the edges, but that's only 9, Chad. Well, I did say we have 10, and we do. You can also drop it anywhere else on the screen that isn't a button, and it will become a freestanding floating window. Today, I'm going to drop it here as a tab. See? Imaging and autofocus now share the same space. I can even rearrange the tabs once here by dragging the tabs around. Alright, enough of that. Time to click the Start Autofocus button. While this is running, pay attention to the focuser position up here, the exposures down here, and the graphed and table data in here. Okay, I moved the focuser 4 times 75 or 300 focuser steps, as we expected, and started a 6-second exposure. It graphed the HFR at this focus position on the graph. move back 75, or one autofocus step and start at another exposure. It plots the results and connects the dots. I'll speed this up, but it'll keep doing this until it plots both sides of the curve around our focus position. Once it completes at all the test points, it uses curve fitting to find what it believes to be the best focus point based on the data. This autofocus run determined the best focus was found at 26347 with an HFR of 319 and a curve fitting R-squared value of 0.98. 1.0 is perfect, so 0.98 is obviously pretty good. A couple of suggestions though. Look at my curve at the top right where we started. Notice how it initially is a little flatter than expected. This is likely due to backlash in the focuser gearing mechanism. Remember when we were testing and moved back to manual focus, but our HFR wasn't as good as we expected? Yeah, it was this. Nina has an easy way to address this issue. By looking at the flatter part of the graph, I'm going to guess at a working backlash measurement. I know from here to here is 100 focuser steps. That may be an okay value for us to start with since it's fairly close to the unusual part of the curve. Let's go back to Options Autofocus and enter that amount in the overshoot backlash out area. You don't need to get this perfect, by the way. Nothing crazy, but close is good and a little over is better than a little under. Oh, and never put numbers in both fields, in or out, but never both. Now with overshoot set, I'll run the autofocus again and speed up the video. Well, that curve looks better, doesn't it? A great HFR under 3 and a 1.0 R-squared as well. So a nice curve, backlash is addressed, my low to high HFR is between a 3 and 4 multiple. I'll take a quick test exposure, and I'm happy with this 2.89 HFR. Take another just because I can, and this one's at 2.97. Never expect them to be the same. It all comes down to star detection, star measurement, and seeing conditions, among other things. Okay, please don't stop here and think you're done with autofocus if you're using filters. 6 seconds for a luminance filter's okay, but will those same parameters work for hydrogen alpha? Let's find out. I'll take an HA image up here, and for the test, we'll stick with the 6-second exposure time. Well, that's not many stars, even in this stretch preview that Nina is showing me. I can go back to Options Imaging and turn on Annotation again to see what stars are being selected for HFR measurements, and then take yet another exposure. Only 9 stars detected for HFR. That's a little risky because right now I'm near focus, and when autofocus for HA moves further away, I'll likely have even fewer valid stars to use. So what exposure length should I use? Well, let's take a test exposure at 10 seconds and find out how that looks. That gave me 19 stars detected and an HFR of 3.36 here. Let's also try 12 seconds. That gives us 26 stars and 3.54 HFR. So what can and should we do? Well, head back to Options Autofocus. Notice 6 seconds is the default, but it can be overridden per filter. I can come down here and override the HA filter exposure time to be 12 seconds. Now let's come back to imaging and verify our active filter is HA as we expected, then run an autofocus on this filter. Notice it's taking 12-second exposures as defined, and I'm of course speeding this up. Not a bad result, but I thought I addressed the backlash, but this looks like I need another 100 overshoot steps. That's a bit odd since I didn't see that after fixing autofocus backlash earlier. Exactly, don't just assume, go ahead and verify. But how can I verify this? Easy. I know the focus position where I have a concern, so let's just go there and take a picture and look at it ourselves. This looks to be just under 26,650, so maybe 26,640 is a good position. Let's go there, then take an exposure. Well, that may be the issue. Way out at the edge of our focus curve, we're getting donuts instead of stars. And not many usable stars either. So this isn't so much backlash, but more likely just a bit far from focus and bad stars not suited well for autofocus. I'm not going to dive in too deep here. These settings should actually be okay for us today, but if you want to dial it in more, you can go watch my Hocus Focus video that digs in far deeper. You might even adjust the step sizes and initial offset steps to tighten up the curve, but be careful not to tighten it up too much, because if you start too far away from focus, you might never find it. I'll move back to the calculated focus position and take an image to verify we're still close. Now while I'm thinking about it, I'll adjust the other exposure times assigned to my 2 additional narrowband filters, since they likely have the same issue. You could test this out filter by filter, but I'm going to move on and assume it's solved today. You can go ahead and run another autofocus test on the luminance filter before we move on to the next step if you like, unless you're already happy with what you see. And by the way, for most people getting autofocus working, that's a pretty big win, so congratulations. So thinking about where we are right now, we have Nina working and taking images, we have the filter wheel working as well, and the focuser, and more specifically autofocus. Not bad for first light so far. Now that we have a focused camera, we can move on to polar alignment within Nina using the 3-point polar alignment plugin. There are several other ways to polar align telescopes, and I actually already have a playlist dedicated to this, but since you're in Nina, let's give that a shot. Plus, this will get you some experience with plugins. Click Plugins, then Available, and locate the 3-point polar alignment plugin from the list. To install it, click Install at the upper right. You need to restart Nina for plugins to complete installation. It isn't ideal to have to restart with all of our equipment already connected, but let's go ahead and do it by clicking Requires Restart. Nina is restarted with no equipment reconnected. Let's reconnect everything. This also reconnected our PhD2 guider, and I'd prefer that no guiding corrections take place during our polar alignment, so just to make sure I'm going to disconnect that from Nina and verify it stopped in PhD2. Okay, back to plugins installed. And we can see our plugin is here. There is some configuration options available, but the defaults are often fine for most users. If we go back to imaging, we can see that the tool is already open and in the same location as our image and autofocus location. We can also see the plugin tool is shown up top as well. I have a view to the north from my location, so I'll only adjust the filter to force use of the luminance filter. If you don't have a view to the area around Polaris, you can use this plugin to align you, but you need to provide an alternative starting point position here based on what sky is available to you. I'm ready to go, so I click the Start button. The mount will slew and take a couple images plate solving along the way. This is validating our mount and ASTAP plate solver, by the way. After the measurements, it tells me my azimuth error, altitude error, and total error. I like to try to get my total error with this plugin as low as possible, but ideally as far under a single arc minute as we can. From this point forward, the plugin will take a new image every 2 seconds and plate solve it, providing updated error amounts and corrective suggestions. I'm going to start with the azimuth error. This tells me to move right or east, so I head over to my mount and turn the azimuth adjustment knobs so that the mount adjusts right or east. It says I'm off by about 2 degrees, so I'll move it to what I think is close to that. Looks like I only moved it about 1 degree, so I'll try again. Okay, now under a degree, but still 32 arc minutes. And still to the right. A quick tip here. See how the adjustment guide box is hanging off the screen after my adjustment? I can bring it back on screen by clicking a new star in the imaging field of view. Let's click this one here. Now I'll go back and try to move it to the right yet again. Let me speed this up so you don't have to watch this back and forth. Let's leave that axis for a bit and try to get the altitude right. It's at 22 arc minutes of error and wants me to move down. I'm going to speed the rest of this up and get it as close as I feel I can get today. I'm happy with where it settled around 30 arc seconds of total error. I'll stop this plugin and assume we're polar aligned. Okay, I took a quick break and maybe you didn't notice, but I'm back and it's now time to set up and validate guiding with PhD2. First, I suggest you make the PhD2 app full screen and adjust the layout to something you like. You can follow my lead here or set it up any way you want. The majority of what you're looking for is here in the View menu. You need to calibrate PhD2 on this new system, and to do that it's advisable that you choose a target that's between negative and positive 20 degrees declination. The target should also be within an hour of the celestial meridian. This isn't 100% required, but does provide the best results. Let me show you one way I use Nina to find a target that will work. Back in Nina, I go to the Sky Atlas, expand coordinates, and set a range of -20 to +20. Let's set the altitude to above horizon to limit our results a bit more. Then click Search. All of these results meet the declination requirements for calibration, but we need to find something that's also near the meridian as well. What we want is to find something that has the dot at the top of the curve, which is where the object crosses the meridian. And we want that to be near our now line, meaning it's close to the meridian right now. As an added suggestion, I like to find something already on the other side of the meridian so we don't run into any mount limits or a flip. If you can't find something you're happy with easily, or maybe you find an object but you want something higher in the sky, we can further limit our search by locating a target near the meridian and then applying a filter that matches that right ascension. As an example, Bernard 43 isn't bad and meets the criteria, but is fairly low in the sky at just 36 degrees of altitude. Looking over here, we can see that it's at a right ascension of 1629.54. Let's go back to our filter and set a right ascension between 16 and 17. There are a few options here. Annabelle 2152 seems to work. It's already after the meridian and meets the other criteria. I'll click Set for Framing Assistant to validate that function in Nina. Looks like it worked, and then I'll click Slew and Center to plate solve in Slew. Once it completes, you can even click Determine Rotation from Camera to view your camera sensor rotation and get a true framing view of the object rather than just centered coordinates. I'm now pointing at a target that meets our requirements for PhD2 calibration. Let's go back to PhD2 and start the process. Our equipment is connected, so I'll start looping exposures. If you're not in focus here, take some time to find focus on your guide scope before moving on. Then click to perform Auto Star Selection. Then hold down the Shift key and click your mouse button on the guiding icon at the same time to start performing a guiding calibration. This will take a bit of time as it moves around while completing the calibration process. Once done, guiding will begin. I like to let this run for a bit so the mount can settle in. Then I like to run the guiding assistant by selecting it from the Tools menu. I let this run at least 2 or 3 minutes. When you finally stop it, it will measure backlash and provide suggestions. You can review and apply these suggestions manually or by using the Apply buttons. I'll adjust the exposure time to 3 seconds myself and apply the others via the buttons. I'll also review the backlash graph that was generated. After closing the tool, I'll clear the graph to get a fresh overall look. At this point, you can just let guiding run, or after the adjustments, if still not happy, you can see if another calibration and guiding assistant round continues to improve your guiding. Now, this wasn't meant to be an all-inclusive PhD2 video, so we can move on by going back to Nina and reconnecting the guider under Equipment. Now, as a final test, let's take a pretty picture. In the Sky Atlas, I'll look for a galaxy that'll work right now. M51 is iconic enough, I think, for a first test. Let's set it for framing and determine the camera rotation. I'm going to move the target off center for this test just to prove framing is as expected in the final image. I'll put it up here in the corner, pointing into the corner, and then slew and center on this framing. Once centered, I can come over to the imaging page and see the solved image looks accurate to my framing request. Now I'll take a single 120-second exposure using my luminance filter and the focus we set a while ago. I won't make you wait the full 2 minutes for the results. Overall, for a first real exposure, I'm happy with this, and the framing matches. Well, that's it. For now, anyway. There's a lot more you can do, including adding additional plugins, installing my shared sequences, and on and on. Watch more of my videos and get some ideas, and feel free to ask questions or contact me if needed. Like and subscribe and share with others. And keep in touch. Hopefully you found this series to be useful. I'll be back with some additional videos soon. I've got a couple more to complete that are already in the works, but I also need to try to find some of my own time to get some imaging done. It's been a while. Speaking of that, here's wishing you some clear skies. It doesn't look like I'm going to be getting any for a while. So please get some clear skies.